In today's video, we will look at the blockchain technology, from its mechanism to Bitcoin and miners. A blockchain, as its name indicates, is a chain of data blocks. It is a growing list of records, called blocks, that are linked together using cryptography. This technique was popularized by a person using the name Satoshi Nakamoto in 2008 to serve as the public transaction ledger of the cryptocurrency Bitcoin. The identity of Satoshi Nakamoto remains unknown to date. Before we dive into blockchain, we should first look at what a hash function is. A cryptographic hash function takes in any kind of message and outputs a string of bits with a fixed length, like 256 bits. This output is called hash of the text. For a given input, the output is always the same, although the output looks like a random series of zeros and ones. If the input message is changed slightly, the resulting hash will change completely and unpredictably. A typical hash function commonly used is called SHA-256, and its output for any input is a binary of 256 bits. It's impossible to compute in the reverse direction. Each block in the blockchain contains a cryptographic hash of the previous block, and timestamp, and transaction data. As blocks each contain information about the block previous to it, they form a chain, with each additional block reinforcing the ones before it. Therefore, it is very difficult to change data in the blockchain because once recorded, the data in any given block cannot be altered without altering all subsequent blocks. The data stored inside a block depends on the type of blockchain. The Bitcoin blockchain, for example, stores the details about a transaction, such as the sender, the receiver, and amount of coins. A block also has its unique hash. Any slight change in the block will result in a totally different hash value. So it's easy to detect whether any change is made to a block, simply by computing its hash. Look at this example. This is a chain of 3 blocks. Each block has a hash and the hash of the previous block. The first block is called the Genesis block, because it has no previous block. Now let's say that you alter some data in the second block. This results in a change in the hash of the second block, which, in turn, makes all following blocks invalid because they no longer has a valid link to the hash of block 2. So changing a single block will make all following blocks invalid, unless all the hashes of other blocks are recalculated accordingly. To prevent such security breach, blockchains invite a mechanism called proof of work, which we will explain in detail through its most important application, Bitcoin. The implementation of the blockchain within Bitcoin made it the first cryptocurrency without a central bank or administrator. There is no central authority to manage accounts or verify transactions. The idea underlying Bitcoin is to verify transactions by network nodes through cryptography, and write transactions in a public distributed ledger. For example, Alice sends 5 bitcoins to Bob, Bob sends 10 bitcoins to Charlie, things like that. Then to make a transaction, like Alice sends 8 bitcoins to Bob, Alice broadcasts that message out into the world for people to hear and write on their own private ledgers. Network nodes can validate transactions, add them to their copy of the ledger, and then broadcast these additions to other nodes. Each network node stores its own copy of the blockchain. At intervals of about every 10 minutes, a new group of accepted transactions, called a block, is created, added to the blockchain, and quickly published to all nodes, without requiring central oversight. This record-keeping service is called mining, since it requires a lot of work and introduces new bits of currency into the economy. Miners keep the blockchain consistent, complete and unalterable, by repeated grouping newly broadcast transactions into a block, and get rewarded with new money for doing so. There are many miners in the network, so how to make sure a block newly created by one miner can be accepted by the rest of the network? The solution Bitcoin offers is to accept the block that contains a proof of work, POW. The POW requires miners to find a special number called a nonce, number used once, such that when the block content is hashed along with the nonce, the result has many leading zeros, as can be seen in this example block hash. This proof is easy for any node in the network to verify, but extremely time-consuming to generate. Miners must try many different nonce values before a result happens to have such many leading zeros. The successful miner finding the new block is rewarded with predetermined newly created bitcoins. All bitcoins in existence have been created through this type of reward. The Bitcoin protocol specifies that the reward gets cut in half every 210,000 blocks, about every 4 years. Eventually the reward will round down to 0, and there will never be more than 21 million bitcoins. In addition to the block reward, miners can also pick up transaction fees. A small transaction fee can be optionally included in a transaction as an incentive for miners to include this transaction in the next block. By adjusting the required number of leading zeros, also known as difficulty target, the amount of work needed to generate a block can be changed. As there are more and more miners on the network, the challenge gets harder and harder, because the difficulty target is periodically changed so that it takes about 10 minutes to find a block. As of April 2022, it takes on average 122,000 billion attempts to generate a block hash with required leading zeros. Computations of this magnitude are extremely expensive. And importantly, all this work is intrinsically tied to that list of transactions. The proof-of-work system, together with the chaining of blocks, makes modifications of the blockchain extremely hard. If one block is modified by an attacker, all subsequent blocks must also be modified accordingly. If there are two distinct blockchains with conflicting transaction histories, miners will trust the longest one, the one with the most work put into it. Another security measure the Bitcoin network adopts is by being distributed. It's a peer-to-peer payment network. Users send and receive bitcoins by broadcasting messages to the network using Bitcoin wallet software. Transactions are recorded in this distributed, replicated public database, the blockchain, with consensus achieved by the proof-of-work system discussed above. An attacker would have to take control of more than 50% of the peer-to-peer network for an altered block to be accepted by the Bitcoin network. Bitcoin mining is a competitive endeavor. An arms race has been observed. Basic central processing units, CPUs, high-end graphics processing units, GPUs, field programmable gate arrays, FPGAs, and application-specific integrated circuits, ASICs, all have been used. These hardwares are assembled together in an arrangement called a mining rig to perform cryptocurrency mining. Crypto mining rigs are in various forms that deliver different degrees of hashing power and mining rewards. In the very early days of Bitcoin mining, Bitcoin miners successfully mined blocks with the CPUs in their laptop and desktop computers. This was possible because there were very few miners at the time. As interest in blockchain and crypto has grown, so have the number of miners. As a result, most miners have moved on from CPUs and started using GPUs, as these systems tend to be more efficient and have a much better hash rate. On top of this, many miners construct mining rigs that have 6 to 12 GPUs each, which multiplies their hashing power. The reign of GPUs was also fairly short-lived. By 2015, the mining of Bitcoin was being dominated by Asic miners. Short for application-specific integrated circuit, Asic miners are designed to do one thing and one thing only: mine cryptocurrency. Asic miners are expensive, with prices typically ranging from $2,000 to $15,000. This is a significant cost and requires some time to attempt reaching break-even point. Computing power is often bundled together by a mining pool to reduce variance in miner income. In a pool, all participating miners get paid depending on the amount of work it contributed. Before we finish, we should note that some investors have characterized Bitcoin as a speculative bubble at various times. Others have used it as an investment, although several regulatory agencies have issued investor alerts about it. My name is Claytab. We create 3D animations on various topics. Go ahead, subscribe this channel for lots more animations just like this one.